Okay, we're back with part 2 of the notes. So we just finished number 5. We're talking about cards, picking cards out of a deck. What happens if we pick 2 cards now? Instead of just 1 card, we pick 2. What's the probability of getting 2 clubs? Well, there are 13 clubs in a deck. So the probability of the first club is 13 out of 52. And then the probability of the second club. Now let's assume that we're not replacing the card, the first card. We keep it out. So there aren't 13 clubs anymore, now there are 12. There are not 52 cards anymore, now there are 51. Now again, there's a lot of reducing you can do with cards. And if you start doing a lot of stuff with probability of decks, you'll start seeing things like 13 and 52 actually reduce to 1/4. 3 goes into 12 and 51. 3 goes into 51 17 times. And one other thing here, the 4 divided by 4, I can reduce that to 1 as well. So what we get is 1 out of 17. So the probability that you would pick 2 clubs out of that deck of 52 is 1/17, which is 0.059. What's the probability that you choose 2 queens? Well, there are 4 queens in a deck, so for the first card, 4 out of 52 to pick that first queen. Now if you pick a queen, there are no longer 4 queens, there's 1 less. So now for the second queen, there are only 3 ways to pick it, and there are only 51 cards left. Now again, we can do some reducing. 4 out of 52 is 1 out of 13. 3 out of 51 is 1 out of 17. And 1 times 1 is 1. 13 times 17 is 221, which is 0.0045. 0.0045. So it's not likely that you would pick 2 queens in a row out of a deck. Less than a percentage. That's actually 0.4%. Incidentally, this would also be the probability of picking 2 aces. So if you ever play Texas Hold'em, where you start with 2 cards, the probability of getting 2 aces to start is only 1 out of 221. Doesn't happen very often. So every 221 hands, you can expect to get an ace. All right, what's the probability that you pick 2 black cards? Well, let's see. There are 26 black cards total. So for the first card, 26 out of 52 times, and the second card is there's 25 left, 25 black cards left, and there are 51 cards left. So what you get here, this is 1/2, and what we get is 25 out of 102, and that is 0.245. 0.245. For that. So it's not quite 25%. You might think 25%. It's close. It's 24.5%. All right, so let's take a game like blackjack. Now, I'm going to tell you that the probabilities here, I'm going to introduce some new concepts. This is not going to be the main idea. So if you get a little confused about this, the thing with probability is that you have to include all the possibilities as well. So in blackjack, or what they call 21, in the game of blackjack, you're dealt 2 cards with the goal of getting as close to 21 as possible without going over. If you go over, they call that breaking or busting, and you automatically lose. All face cards, and that includes the 10s, they count as 10 points, aces count as 1 or 11 points, depending on how that helps you best. For your starting hand of 2 cards, so you always get 2 cards to start, what's the probability that you start with a value of 20, which is actually a great hand if you get that first? Now here's the thing you got to think about. Well, how can I get 20 points? One way is to get 2 values of 10. Now when I write down 10, 10, that doesn't just mean the number 10. It could be a king, a queen, or a jack, because those are all worth 10 points. So if I get 2 10-point cards, that would give me a 20 value to start. Well, How many 10-point cards are there in a deck? There are 12 face cards, okay, 12 face, but also 4 tens. So there's a total of 16. So that would be 16 over 52. Now if I pick any kind of 10-point card in my first card, now there are only 15 left to choose from. And there are no longer 52 cards, there are 51 cards. And if you work this out, the fraction would be 20 over 221. Okay, if you don't believe me here, we can do 16 divided by 52 times 15 divided by 51. Now we're going to get a decimal, 0.09, math, enter, enter, 20 over 221. So it's about 0.09 for that. 0.09, I'll say 0.5. So it's only about a 9% chance that you would start with 20 from a 10 and a 10. However, that's not the only way that you can get 20, because the ace counts as 11 points. So if I get 11 and 9, that is also a starting hand of 20. Now here's the thing though. It doesn't matter if I get ace 9 or 9 ace. So what I'm going to do is calculate both of these. If I want to get ace 9, there are 4 aces out of 52 cards, and there are also 4 nines, but now there are 51 cards. So notice this number doesn't go from 4 to 3 because these are two totally different cards. 4 aces, let's say I pick one of them. To get the 9, there are 4 nines, so again, that's 4. So what we end up with, if you reduce this, you're going to get 4 over 663. Okay, so that's very small. Now, let's say we wanted to go 9 ace. Well, 4 nines out of 52, and then 4 aces out of 51, and what happens is you get the same thing. If this is a problem where it could be this or this or this, what you do is you add the probabilities at the end. 4 divided by 663 is 0.0060. 0.0060. So if I want the overall probability of getting a total of 20 to start with 2 cards, I would add these up. So I would take this, I'm going to multiply that one by 2 because there's 2 of these, and then I'm going to add the 0.0905. So to get a starting hand of 20 in blackjack, you have about a 10% chance. Okay, so overall is 0.103, 10%. Okay, so in other words, it doesn't happen that often. If you play 10 hands of blackjack, you can assume on average one of them will give you a value of 20 to start. Okay, so by doing this where I'm adding probabilities, I'm getting into stuff that's a little bit more complex. Okay, but again, if this is confusing, this is not the most important thing. I'm just trying to introduce some game theory here to you. So let's look at the probability of 21. And actually, again, for your starting hand of 2 cards, if you get 21, that's what we call blackjack. You automatically win, as long as the dealer also does not have blackjack. Now, how do you get blackjack? How do you get 21? Well, you'd have to have 11 points and 10 points. So you can either get ace and 10, or you can get 10 and ace. So again, what I'm going to do is I'm going to calculate these separately, each scenario. So to get an ace and then a value of 10, there are 4 aces out of 52. Now, the cards that have 10 as a value, well, that's going to be 10, jack, queen, king. So that's 4 types of numbers. That's a total of 16 cards, 4 of each, out of 51. And what that reduces to is 16 over 663. Now, what if I get a 10 and an ace, which is also a blackjack? Well, there are 16 10-point cards out of 52, and there are 4 aces out of the 51 remaining cards. And again, it's 16 out of 663. Okay, so what I would do then is I would add these up. Okay, add those up. You get 32 over 663, but that doesn't really make a lot of sense. We work better with decimals in this situation, so it's about 0.048. 0.048. So it's almost a 5% chance of getting a blackjack. 5% is about 1 out of 20. So if you play 20 hands of blackjack, you can expect, not that it's always going to happen, but you can expect to have 1 blackjack for every 20 hands. All right, now, the way that the game works is so you get your 2 cards, and then the dealer starts with 2 cards, 1 face up and 1 face down. So they show you 1 card, but not the other one. Let's say the dealer's showing an ace. So ace something. What's the probability that they have a blackjack? Now you have to understand here that in most places where you would play this, it would be more than 1 deck of cards getting played. It would be almost, it could be 6 decks, it could be 8 decks all mixed together. So to get a 10-point hand, or a 10-point card, that could be a 10 jack, queen, king, ace. Now that's 16 cards total. Let's assume that this is out of 1 deck. Now you're going to say, wait a minute, they already have an ace. So shouldn't it be 51? Technically, yes. But if you're dealing with 8 decks, losing that 1 card isn't going to be such a big deal. So it's approximately, and this is an approximation, 16 out of 52, which reduces to 4 out of 13, which is 30%, 0.308. So if the dealer is showing an ace, there's a 30% chance that you've already lost the hand, that they have a 10 underneath that they haven't shown yet. Okay, so you don't want the dealer to have an ace. That's a bad situation for you. Now, if the dealer has 16, what's the probability that they break with their next card, that they bust? So what's the probability that they go over? If they get higher than 21, they automatically lose. And if you're still in the hand, you win. So 16 plus something has got to be greater than 22. Or equal to. Greater than or equal to 22. So if I subtract 16, what we get, I'll call that x. X is greater than or equal to 6. So if the dealer has a 6 or higher as their other card, okay, after they have 16 points, so if they have to hit, if they have to take another card, what's the probability that they break? Well, so anything higher than a 6. 6, 7, 8, 9, 10, jack, queen, king. Not an ace, because an ace counts as 1 or 11. So if the dealer has 16 points and they get an ace, then they have 17. And that might hurt you, because then they stop. So if they get any of these cards, though, if they have 16 points already and they pull any of these, they lose and you win. 1, 2, 3, 4, 5, 6, 7. So that's basically 8 cards. The probability of greater than or equal to 6 is approximately 8. Now I'm going to say 8 out of 13 because 13 is the type of card that they would lose on. Ace, 2, 3, 4, 5 are no good for us. All right, so I'm thinking ace, 2, 3, 4, 5. These are the ones. So out of the 13 types of numbers, 8 of them would help you, but the other 5 would not. 8 divided by 13 is about 61.5%. Whoops, 0.615. So if the dealer has 16, that is the most common break hand right there. There's a 61% chance that when they take their next card, which they have to do, that they're going to break. That is the end of part 2. So continue on to part 3 and we'll talk about roulette.